Okay, I'm going to walk you through my solution to Project 2 here. And I'm reshooting this video sequence because I've made some refactorings that I'd like to be sure that I show you. I've simplified it after having some discussions with students and seeing what isn't clear. Anyway, here's how the app works at this point. You launch it, it comes into this configuration with temples in the collection view on the left that you can scroll through, names on the right that you can scroll through. You notice I have not only the temple name but also the country or the state associated with that temple. And for some of them, like the Salt Lake, actually I need to reload. I must have already matched Salt Lake there. Anyway, if I look at Salt Lake, you see it does not have a country or a state associated with it. It's just the Salt Lake Temple. Provo City Center is another one like that. Okay, and take a look at the temple cards. I have a white border of about 5 points. There's a really fine gray border that's just 1 pixel wide. In study mode, you'll see that I have names, and there's that little rectangle that does, basically I'm doing an alpha blend of this rectangle over the image behind it. And I've torn out some of the features that you saw the first time I demoed this. So the index along the right hand side, that just made the model a lot more complicated, and so I've torn that out. I don't have a large image. You can't double tap and zoom in on a temple photo. And I don't have a sound playing. I just have it shaking to animate. I don't have it playing a sound. But you can go and look at the history in Git, and you'll see, if you tap on that there are a whole bunch of commits. But you look back here, right here, here's the commit that removes the temple names index. And if you go and double click on that guy, you can compare what changes I made to tear that stuff out. And so you can see the amount of code that it took to implement that fancier model. And you have to go to the other files and look at that as well. Or if you go back to removing the sound playing feature, for example, you'll see I deleted the wave file, I deleted the soundhelper.swift, but there's the soundhelper file. What changes in the app delegate? Well, a few things there, and in the temple view controller, just 1 line. So if you want to go back and look at those other features, feel free to do that. You just need to rewind the commit. You go to source control and you would check out a particular version of that. But Google about that if you want to learn how to use Git. Let's start with a model. Okay, so my model, at the lowest level, I have a temple class. Temple class, it's a foundation object. I have a name and a subtitle, so title subtitle field for the temple basically. I also store the dedication date of the temple, a file name of the image, and I am caching the height and width so that I can make some size calculations pretty low cost without having to go open up files, image files, to figure out what that is. So those properties, 6 properties, and then an initializer for those things. And from that, I can build a list of temples. So in particular, here's my list of all of the temples, and I've got 140 something, whatever that number is. So, and you see the dedication dates and the sizes associated with those. Now this is the ultimate truth in my application. All of the collection view, the table view, everything is going to come back and get temples that are out of this list right here. But let's see how we do that. I've built a game engine class, and this class, so I've got a nested type for the mode, whether I'm in game mode or study mode, a bunch of messages. This is the stuff I'd need to translate if I'm going to localize the app. And then a few other constants like my match score. I give you 5 points for getting a correct match, and I take away 3 for an incorrect. And there's a time bonus that if you finish in less than 1,500 seconds, you match all of them in less than 1,500 seconds, then you'll get a time bonus. And so you can try to get a higher score than you did before or something like that. In the game engine, here are the properties. So, actually I don't really need that blank line, but so I've got the correct and the incorrect matches. I've got the current mode, whether it's game or study mode. I have the current score. When did we start playing, so that I can calculate the time bonus at the end? What is my current status message? And then I have these 2 integer arrays that are intended to be indexes into my temples list, that ultimate truth I told you about before. The temples list lists all of the temples, but these arrays are what are going to back the collection view and the table view. So when I match something, I'll pull the indexes out of these two arrays. And it's the size of these arrays that controls how many temples and how many names are listed in the collection view and table view, respectively. I have a bunch of computed properties that are based on those other fundamental stored properties. So, for example, I have an isStudyMode that gives me a Boolean that says, hey, is my current mode study or not? I have a gameIsOver. If my number of temples is less than or equal to 0, game's over. And temples count, well, that's a computed property that just looks at those, one of the arrays, temples by name and temples by photo always ought to have the same size. And so here, this is going to just use, I could have said photo here instead of temples by name, temples by photo. But anyway, return one of the counts of those two things. So you see, I'm using computed properties to give me things that make sense that the view controller is going to need, but really the operation belongs to the model layer to tell me what is my current status message or score message. In study mode, I don't want to show one. In game mode, I do want to show one. So going back over here, I go to study mode, and you see that status message went away. But back in game mode, yeah, those things show up again. Okay, now, so you can look through the computed properties. The initializer, pretty straightforward, just start off with a default status. Excuse me. Then the temples by name, we just build an array from 0 to the count -1. This is how you build an array of integers quickly in Swift. And then the temples by photo, so the scrambled one, we'll take that name array and we'll shuffle it. And that gives us the indexes for the collection view. These are the indexes for the name, the table view. Other helpers. So when I delete a temple, I need to know what is the index path of the name and of the photo, and so we just go to those respective arrays and remove those index paths, or the item at those rows. And then if game is over, then we need to finalize the score, calculate our time bonus, and then some other helpers. If they do a correct match, we need to update the model to match, to add the 5-point bonus and stuff like that. And similar for the incorrect matches, and then some helpers to access a temple object for a given index path. So if I need to know the temple object for the table view at a given index path location, I can call this method. And similarly for the collection view, the thing that's special about the collection view, in study mode we want the full list. In game mode we want just the list of unmatched temples, those that have not yet been matched. And so we do need to check that and go back to the underlying list in study mode. And then a little toggle here that says, hey, if we're in study mode, let's go to game. Otherwise, we're in game, so go to study. So that's my model layer. And I think that's a pretty decent architecture for the model layer. Now, in this video, let me show you a couple more things, and then we'll put off to the next part doing the model or doing the view and the controller layers here. But let me show you the supporting files. So first of all, I've put all of my images into a folder here, and I've got both the full size and then the thumbnail size. I guess you can't really see the full name. But as I scroll through here, do I see any thumbnails? Oh, it's in a subfolder. There they are. Okay, so I've got all of these images, and I did a lot of processing to work that out, but anyway, so that's where I have the images. I didn't put them into images.xc assets. And then on the utilities and extensions, here's some cool little features. So here's an extension to the built-in array type. Array is a struct. And so because it's a struct, when I assign an array to a variable, so I'm building a copy of myself. That's what this extension does when we call shuffled. Build a copy of myself in source array. Then let's build an empty array that I call shuffled array. And as long as the source array has something in it, let's go remove an item at a given index from the source array. That's this little bit. And let's append that item onto the shuffled array. And this recipe right here is the fair way to get a random integer between 0 and count -1. Anyway, when that's all done, return that shuffled array, and this will work on any kind of array. That's kind of cool. Here is the helper that does the shake animation. You go to this bit.ly URL and you'll see the Stack Overflow discussion of it. But we built a thing called a CA keyframe animation, so core animation, keyframe animation, and we're just translating left and right 8 points. Auto reverses, we have some count passed in, and anyway, we just go and do that. The other thing on the string extension here, I have two. One is a subscript operator that says, now I just use square brackets on string and I can get the ith character back. That's what this little thing is doing. And then this attributed with shadow, I need to calculate shadow and, well, I need to calculate attributed strings in white and black for both a title and a subtitle. And there's enough going on here that I thought, let me just build that in as a string extension, and then it makes my temple photo view class simpler. And so this is saying, let's go build an attributed string, and then let's make a copy of that so we get one that's white and another one that's black. And return those as a tuple. So if I have two things to return, I can put them in a tuple like this, the attributed, the white string and the black string. Okay, I think that's enough for this part. In part 2, I'll walk through the view and the controller layers here.